First client that we dealt with in terms of cloud search was an advertising agency. And they're like, can you give us something more human and more emotional? So this is my favorite picture of my niece. It's a baby picture of my niece. I put that up there to pander to the crowd. The second thing here is a picture of space and then a logo. Now, for all the material guys out there who are cringing, like, oh my God, I'll give you a nice blank background so you can start with something that's more familiar. Here are my data sources. All the stock data sources, just like cloudsearch.google.com, are at the top. Below, each of the third-party data sources is listed with a little 3P moniker, so you can tell they're third-party, right? So when we go into, let's say, our public web server, and we search for something like Techne, I have to plug Augusto up here, so we won the Techne Award. Not only does the search result return type by iconography, which is a very typical pattern, we all understand that from the old days, right? But when we go into the preview, it will pull the actual website that has that content piece and now allow you full content inside of that site with context highlighting. In this case, I chose a googly blue, right? So inline, our search terms are being highlighted so we can know the thing we were looking for is present. It's a cool thing, right? I mean, we could even chat with Augusto if we really wanted to. I don't think we want to do that right now. Another thing we can do is look at that same file I was saying before about not returning a name. So because of MIME type recognition, end of file recognition, and file type recognition, the parser that we're using to give the preview knows this is a text file. It's not HTML. So it takes the text and actually parses it correctly with its line breaks, again, as you go through with context highlighting. If I could get this interface right. So there you go. Looking for science? You found some science. There you go. Likewise, non-typical text files, which are a ham-based ending, for instance, by MIME type was detected to be text. So we can parse it in the way that the system knows. We went into the Git demo, and to show the faceting still works. So now we're pulling actually the Git page for this piece of code so we can go in and look for the information, the technical information, without leaving search. Know immediately, is this what I want or not? I got the information. This is my endpoint. Boom, I'm done. We're good to go. Salesforce. Let's do some Salesforce data. And I'll pull up Carpenter because they have a cool website. So if we pull up Carpenter, I marked Salesforce data with a SF icon, but inside of the object metadata, we can tell what type of object it is. Is it a contact? Is it an account? There's several different types that we ingested. And thanks to the kind people at Ration, we got a nice little mix. So this one is a contact. All the contacts will pull up and map. And because of HTML5, I can actually have this entire site context asking for my location, and also track directions from Gmaps embedded. So if you're on your phone and you're pulling up a contact in Salesforce, boom, how do you get there? It's already running. It's already working. You don't have to requery it. Now below, this is an account. So this kind of text-based output is kind of cool, but what's more cool is if we can give that thing, oh, sorry, this is the website. I'm ahead of myself. So this is the website for the account. You know, same thing as we've seen before in preview. And here's an opportunity. So by formatting the data this way, versus like reading it as a bunch of lines on the screen, we have colorization, we have spacing, parsing, elements of design that let me go, oh, okay, this is exactly what I wanted. I can see we closed it, no. We want it, no. Open activity. We can color code it. We can do all kinds of things to make you ingest what this content means quicker. Okay, Vision API, the thing everyone's looking for. So this has been done before. I'm just going to pull all the content items. This is the way our Vision API data is presented at the result layer. So not only do we have the thumbnail, the name, the labels that the Vision API kind of pulled for us, but this is the color spectrum of the major colors that are present inside of the image. And the bar graph is the relationship between what's called a score, which is the most relevant colors for the central focus of the image that the ML believes is the central focus. Then the percentage is how many percent of the total pixels are this color, and here are the top results. Furthermore, because we are, again, talking about making it more useful and pulling in metadata, this is a sign that says love is like a bottle of gin, but a bottle of gin is not like love. We can actually see through a metadata layer the words that were found and where they're located in the image. And this is not like an overlay. This is a canvas element, an HTML5 canvas element that's overlaying this image that will scale with the image, drawing vectored lines that give you the isolation of where these things are. Now, if you go a little bit deeper into this and say, what else can we do? If I had time, I'd pull video. Because if we take every frame of video and analyze it through vision, we can see things such as like, well, is there violence in this image? You know, if so, in this surveillance montage of different images, mark that index. You know, this is like, you know, frame number 42, frame number 58. Then in the preview, when we pull the preview of the video inside of the result layer, we overlay once again one of these canvas elements. It'll take you to the index where it detected this violence,